Hello, chemistry students. Trying to make it so that the video isn't wavy like last time. Okay, so I promised that I'd give some examples of balancing chemical equations and how to mathematically go through it. In the last video, I showed you the concept behind what we're doing to the chemical equation. Again, to reiterate, what we can do is we can change coefficients. We can change how many of each molecule we have. We cannot change the chemical formula of those molecules. So, what we do in balancing a chemical equation is we first look at the unbalanced chemical equation of how the reactants are forming into products, and we count the number of each element on each side. So I have several unbalanced equations here for you, and we're going to go through each one step by step. So we look at this one. On the reactant side, we have one aluminum atom, sorry. We have 3 molecules of nitrate, 3 molecules of NO3. We have 2 molecules of sodium, or 2 atoms of sodium, and we have 1 carbonate molecule. So we have 1 CO3 group. And then on the product side, we have 1 sodium, we have 1 nitrate molecule, 1 NO3, we have 2 aluminum atoms, and we have 3 carbonates, 3 CO3s. So, as we can see, the numbers are not balanced, and our goal is to make the numbers on each side balanced. So to start, we select an area that's easy to fix. Let's say we start with aluminum, because I see that there are 2 aluminums over here and only 1 over here, so that seems like a pretty easy fix. What I'll do is I'll take this and now I'll say, okay, instead of 1 aluminum nitrate molecule, we now have 2 aluminum nitrates. Since we have 2 aluminum nitrates, each aluminum nitrate contains 1 aluminum and 3 nitrates. So if we have 2 of these, that gives us now 2 aluminums and a total of 6 nitrates. So aluminum is now balanced. We have 2 on this side and 2 on this side. However, nitrates, even worse than it was before. Now we have 6 nitrates on this side and only 1 on this side. Again, that's a fairly easy fix. Since each sodium nitrate contains 1 nitrate molecule, all we have to do is multiply this by 6 to create 6 sodium nitrates. So now we have 6 nitrates, same as on the left side, but now we also have 6 sodiums, which is not the same number as on this side. So let's go through now and fix the sodiums. When we do that, we're multiplying by the number of sodium carbonates we make. Each sodium carbonate contains 2 sodium atoms, so in order to make the same 6 sodium atoms that we have on this side, we'd multiply by 3. So 3 times 2 gives us 6 sodiums, and 3 times 1 carbonate, remember each sodium carbonate only has the 1 carbonate, we make 3 CO3 molecules. And then if we look at our equation, we now have 2 aluminum, 6 nitrate, 6 nitrate, 6 sodium, 6 sodium, 3 carbonate, 3 carbonate. And this is now balanced. So our coefficients are 2, 3, 6, and 1. And we would read this equation as 2 aluminum nitrates react with 3 sodium carbonate molecules to produce 6 sodium nitrate molecules and 1 aluminum carbonate molecule. So that's the general idea. All we're doing is adding coefficients, and when we add a coefficient, it changes the number of each type of element or molecule on each side of the equation until eventually it's balanced. So the other 2 examples I have here are combustion reactions. And combustion reactions work a little bit differently. Ultimately, the procedure is the same, but there's a certain order to go through that will make it easier on you. The way I like to remember it is CHO, carbon, then hydrogen, then oxygen. We'll balance all of the carbon first, then all the hydrogen, then all the oxygen in that order, and that'll make it a little bit easier on us as we go along. We won't worry about balancing hydrogen until all the carbon's done. We won't worry about balancing oxygen until the carbon and the hydrogen have already been balanced. So let's go through this process. On this side of the equation, we have 3 carbons, 8 hydrogens, and 2 oxygens. And on this side of the equation, we currently have 1 carbon, 2 hydrogens, and 1 oxygen. So, balancing carbon first, we will multiply this carbon dioxide by 3 in order to create 3 carbon dioxide molecules on this side of the equation. So that gives us 3 carbons. Again, we're not going to worry about how many oxygens are created until the very end, because this water also contains oxygen, so it'll screw us up when we change the number of hydrogens. So we balanced carbon. Next we'll balance hydrogen. So we have 8 hydrogens on this side. In order to make 8 hydrogens on this side, we'll multiply water by 4. So that means that we now have 8 hydrogens. Everything works out okay. Now we go to balancing oxygens. So from these 3 carbon dioxides, that gives us a total of 6 oxygen. And from these 4 waters, that gives us a total of 4 oxygen. And so the total oxygen on this side means that we have 10 oxygen right now. So how do we make 10 oxygen on the left side? Well, we would take this O2 molecule and we'd multiply by 5. That would give us a total of 10 oxygen. So we now have 3 carbon, 8 hydrogen, 10 oxygen, 10 oxygen. And this is a balanced equation with the coefficients being 1, 5, 3, and 4. Excellent. So that wasn't too hard. What is it that makes balancing combustion reactions difficult? Well, let's take a look at this example from your homework before in order to see why this can potentially be complicated. So we'll go through the same procedure. On this side, we have 8 carbons, 18 hydrogens, and 2 oxygens. And again, we have the same starting conditions of 1 carbon, 1 carbon, 2 hydrogens, and 3 oxygens. I should have had three oxygens up here before. Sorry for that mistake. 2 from the carbon dioxide and 1 from the water. Anyway, so we balance in that order: carbon, then hydrogen, then oxygen. So we have 8 carbons on this side. In order to make 8 carbons on this side, we'll multiply by 8. Pretty simple. That fixes that. 18 hydrogens on this side. In order to make 18 hydrogens, we'll multiply by 9. That gives us 18 hydrogens. So carbon and hydrogen are balanced. If we look at oxygen, though, here we start to run into a problem, because right now we have 16 oxygens from the 8 carbon dioxides and 9 oxygen from the 9 waters. That gives us a total of 25 oxygen, which is a big problem because our only oxygen producing molecule over here is O2. We cannot multiply anything by 2 and get 25. That will only ever be able to get an even number. So my advice is, when you run into a problem like this, the best thing to do is start from the very beginning again, but put a 2 here in front of whatever the hydrocarbon is. That will help you to balance the equation. So if we start over from the very beginning, and reset to there being 2 of these, that changes our numbers. And what that'll do is make everything into even numbers so that ultimately we'll come up with a solution. So right now we have 16 carbon, we have 36 hydrogen, and we have 2 oxygen. And on this side we have 1 carbon, 2 hydrogens, and 3 oxygens. So balancing in order, we need to make 16 carbons, so we'll multiply that by 16. That fixes that. We need to make 36 hydrogens, so we'll multiply this by 18. 18 times 2 would give us 36. And then for oxygens, we now have 32 oxygen on this from these 16 carbon dioxide molecules, and we have 18 oxygen from these 18 water molecules. Adding those up, that gives us a total of 50 oxygen. We can make 50 oxygen on this side by taking this O2 and multiplying by 25. and that gives us 50 oxygen. So now we have 16 carbon, 16 carbon, 36 hydrogen, 36 hydrogen, 50 oxygen, 50 oxygen. So our equation is balanced with the coefficients being 2, 25, 16, and 18. Okay, hope that helps. That gives you some basis on some of the more difficult balancing equations that you'll run into. Most of them are pretty easy as long as you keep this table. I haven't seen a lot of you keeping tables like this on both sides, and I feel like it would really help you if you wrote those out, so make sure that you do that. Thank you very much for your time, and I hope that you'll tune in next time.